Not from router number 2. If you want to forward from R3, means from any another path, you should be able to do that. You should be able to filter or clean the routing table of router to get the best performance, right? That is route filtering. At the same time, if there is any issue, you should be able to troubleshoot. Like in troubleshooting, you will just compare destination with routing table. If route is present, definitely router will take forwarding decision. If route is not present, that means there is some issue with routing. You will check the routing protocol. And we know whatever routing protocol we are going to use in the production, like EIGRP, OSPF, BGP, ISS, all maintains a neighbor table, right? Where it is going to store the information of neighbors. If I am not able to find any route in the routing table, first I will verify the routing protocol, that which routing protocol I am using. After that, I will check the neighbor table, that neighborship is up or not. If neighborship is up, then I will expect the route in the routing table. If still it is not available, I will look up topology table, that here routes is available in the topology table or not. So whatever your dynamic routing protocol, whatever tables your dynamic routing protocols are maintaining, you should have information about those tables, like what are the components, like in neighbor table of EIGRP, what we had seen. In the EIGRP neighbor table, how many informations were there? Neighbor IP address. Neighbor IP was here. Yes, neighbor IP address. Then
SRTT, RTO,
update
queue count,
time, hold on time, SRTT, RTO, queue count,
sequence number,
sequence number, and then queue count. Queue count should be what? Queue count.
0.
And what is queue count?
In query count, I think.
Correct. Right. Router is waiting for reply. Router is waiting for reply, means whenever router sends query message, router expect what? Reply. When router sends query message? When router sends query message?
When a link goes down.
Topology change.
Topology change. Yeah.
When any path goes down and feasible successor is not available, right? If feasible successor is available, will router generate query message? No. Sometime interviewer is asking this question: how to reduce? Router is generating lots of query message. How to reduce that? You answer, simple answer is just add the backup path. If backup path is present in the routing table, router will never generate query message. So IP EIGRP interfaces. You can see EIGRP is enabled on my all interfaces. And here I have told you one thing, that as soon as you will enable EIGRP on, EIGRP doesn't work on router, it works on the interface of router. And whenever we enable EIGRP on any interface, it joins the multicast group 224.0.0.10 and it will start sending a hello message. From the LAN interface, you have to stop that hello message. How you will do that?
We'll create passive interface.
We'll configure passive interface. Router EIGRP yes number 10 and passive interface G0/2. Now router will not send any message of EIGRP from 0/2. Similarly, in OSPF also you can configure passive interface. In all dynamic routing protocol, you can configure passive interface. Now, if I will configure EIGRP as number 20 on router number 2, will neighborship come up?
No.
No, sir.
What are the neighborship parameter?
AS value, AS number and K values must be same.
AS number and K values. K values means what K values I am using, right? To calculate the metric. To calculate the metric. Today you will learn in EIGRP, we call metric to FD. What we called? FD to the metric in EIGRP. Right? You can also say metric, that is also fine. But FD means feasible distance, total distance from source to destination. There are some components, today we'll discuss that also. Let me first configure this topology.
Are you recording, Praphul?
Yes,
Okay.
recording is started. So now on router number 2, here is my configuration. Let me copy and paste. Also, let me change the host name, say R2, and I'm going to write the configuration. Let me write the configuration of R1 also, because in future classes also I will be using this topology. I'm just saving the configuration after removing routing protocol. No router EIGRP as number 10. So this topology has just base configuration. Base configuration means just the IP configuration. No router EIGRP as number 10. On router number 3, IP address is going to be 13.3, 13.1.1.3, and on G1/0 IP address is going to be 34.1.1.3. Let me copy from here and let me paste it on R3. Okay, host name R3 and save the configuration, right? And finally last router R4. F0/0 will have IP 24.1.1.4. G0/0. G0/1 will have IP 34.4. And here on G0/2, 2.100. Let me copy it and paste it on R4. So I did the IP configuration on all routers. Let me save the configuration of this router also after changing the host name, right? Now to enable EIGRP on all the interfaces, I can use network 0.0.0 command. See, on R1, how you will enable EIGRP: config T, router, EIGRP, and then ES number. You know the range of autonomous system number. Guys, there are two modes of EIGRP: classic mode and named mode. Right now we are learning classic mode, right? This is also called numbered EIGRP mode. Okay, later you will configure run EIGRP process with the help of name also. I can also say like CCIE, router EIGRP CCIE. We'll see that configuration later. For now, EIGRP as number 10, network 12.1.1.0. You can also use the wildcard mask here. You can use subnet mask or wildcard mask. I'm expecting you all know the wildcard mask. Wildcard mask is going to be 0.0.0.255. Wildcard mask is nothing but just opposite of subnet mask. Subnet mask define how many network bits and how many host bits are there in a particular IP address or subnet, and wildcard mask actually tells how many bits I need to match. So here 0 means must match, 1 means ignore. So how many zeros are there? 24 bits are zeros. Means through this wildcard mask we are telling to match 24 bits, first 24 bits. If there is any interface where first 24 bits are matching, router will enable the EIGRP protocol. So after running this command, do so.
So what's the difference? What's the difference between using the wildcard mask and using the subnet mask?
The same difference which I told you. Subnet mask identify host bit and network bits. Wildcard mask define
No,
how many bits I need to match.
I know, I understand. I'm asking in the configuration side, we can. There's no difference if we use either the subnet mask or the
Correct, correct.
wildcard mask.
No difference.
Okay, that's what I wanted to know. Okay.
So IP EIGRP interfaces. You can see EIGRP is enabled on G0/0 interface. If I want to enable it on all interface, 0.0.0, and passive interface G0/2. Great. My EIGRP configuration is done on router number 1. Let me take you to R2. And on R2, if I will configure router EIGRP as number 20 and network 0.0.0, will EIGRP neighborship come up?
No.
No.
Yeah, because the AS number is different. No.
AS number is not same. So here, so IP EIGRP interfaces. If you will run this command, you will see EIGRP is enabled on both interfaces on router number 2 also, and on both all interfaces on router number 1 also EIGRP is enabled. So IP EIGRP interfaces, EIGRP is enabled, but EIGRP neighborship is down. So IP EIGRP neighbor. So you can see there is no neighbor. Why? Because here ES number is 10 and here ES number is 20. 10 and 20, or you can use a global command, universal command, so IP protocol to identify the routing protocol. Autonomous system number is 10 on router number 1 and so IP protocol autonomous system number is 20 on router number 2. If you will enable debugging on both the router, you will see both the routers are sending hello message on this link, but router in the hello message of R2 ES number is going to be 20, in the hello message of router 1 hello message is going to be ES number 10. That's why this router cannot become neighbor. If I will replace EIGRP protocol from R2, no router EIGRP as number 20 and router EIGRP as number 10 and then network 0.0.0, my EIGRP neighborship will come up. And here is one command, matrix and wait, and here you can define the notos K values, right? Do you want to use K1? Yes, by default EIGRP uses K1 and K3, K2 0, K3, yes, it should be 1, it is using K3, but if here I am going to use K4 also, let me say 1 and here 0. So now router 1 is using K1 and K3 to calculate matrix and router 2 is using K1, K3 and K4 to calculate matrix. That's why again your EIGRP neighborship is down and here you are getting a error message. What is that? K value mismatch. So here you can understand like K value. Let's suppose, see earlier EIGRP was Cisco proprietary protocol, but nowadays EIGRP is open standard protocol. You have one Cisco router and one non-Cisco router. Cisco router is using K1 and K3 by default to calculate matrix and non-Cisco device is using K1, K3 and K4 to calculate matrix. In that case, manually you have to set the same K values on both the router, then only your EIGRP neighborship will come up. Got it guys? This is basic troubleshooting. Troubleshooting of EIGRP neighbor table. There are only two things, ES number and K values, right? And we know subnet should be definitely same. If subnet is not same on router 1 and router 2, then definitely no any dynamic routing protocol can work. Even you cannot ping, that means there is no reachability. So dynamic routing protocol will not work. Here, see neighborship is down. Again on router number 1, if I will run command so IP EIGRP neighbor, so IP EIGRP neighbor, then you can see EIGRP neighborship is down, right? Do so IP protocol. This is the command through which again you can verify. Here you can see K1, K3 and K4. Router 2 is using these K values to calculate matrix and do so IP protocol. Router 1 is using so IP protocol. Router 1 is using K1 and K3 to calculate the matrix, right? So that is the mismatch here. Because of this your EIGRP neighborship is down. So let me remove this command from here. Again my EIGRP neighborship will come up. Two basic troubleshooting of EIGRP neighborship. Now router number 1. Router 1 is advertising one LAN which is 192.168.1.0 to their neighbor. Is their neighbor, so IP EIGRP neighbor. So IP EIGRP neighbor. Yes, 12.1.1, sorry, 2 is the neighbor of R1. So whatever prefixes are present in the routing table of router 1, like how many prefixes are present? 3. So IP route, you can see. Forget about this, right? Because it has learned through EIGRP, R2 has advertised it. But if router 2 is not advertising any prefix, then router 1 has 3 prefixes in their routing table, 3 networks. So except the network which is running on exit interface, it will advertise all the network, entire routing table. 1 minute guys, getting next call. Yes. So keep in mind here two things, that router is going to advertise entire routing table except the network which is running on exit interface. And what will be the source and destination IP in the update message? Source will be the IP address of exit interface and destination depending on protocol. If the routing protocol is using multicast address, then destination address is going to be multicast, and through the source address only R2 will learn the next hop IP address. Like R1 is going to advertise 30 network and this 192.168.1.0 network to router number 2. On router number 2, if you will check routing table, so IP route EIGRP, you can see it is learning both 13 and 192.168.1.0, and next hop IP address is 12.1.2. This was the actually source in the update message. In EIGRP, we have discussed 5 types of messages. Hello message used to discover neighbor and keep alive. Update message used to share network information. Query message used to inform neighbor about network down and to ask for alternate path. Reply is the response of query, and last message is the acknowledgement message, because EIGRP is a reliable protocol. Correct? Till here we had discussed in EIGRP. After that, I have discussed ACL, access control list, because I am going to use ACL in our dynamic routing protocols. All clear? Then metric calculation also. We had seen the formula 10 raised to power 7 upon. I had asked you one question, why we are multiplying the formula by 256. If anyone have found the answer, please share. If all till here are clear, then please tell me so that I can move further.
May I know like why we are using passive interface again? Sorry.
Sorry?
Passive interface.
We are configuring passive interface to stop EIGRP messages on the LAN interface.
Oh, okay. Thank you.
Welcome. And so IP EIGRP neighbor. We had also seen how router is going to calculate SRTT time. Here you can see yesterday's SRTT time was different. Today it is different, right? Even RTO time is different. So this is not a fixed formula or fixed value. Every time whenever router will discover their neighbor, it will calculate SRTT and RTO time. One more thing, if a router has advertised some prefixes to their neighbor, means it has sent update message, and router have not received the acknowledgement, in that case what will happen? Router have advertised network update is a reliable message R1 R2. .1.0/24. So router 1 has advertised this submit through update message to router number 2. Update with this network information 10.1.1.0/24, and it will advertise the K values. K values, let's suppose K1 and K3 like this, right? And other K values also. Now router 2 should send acknowledgement, that is normal operation. But if router 1 is not going to receive acknowledgement, then what will happen?
Neighborship will not form.
No. Neighborship is already there. Router advertise prefixes or sends update message to their neighbor only.
Routing table will not update.
Router will start sending unicast update message. It will start sending unicast update. First update was multicast. Now second update is going to be unicast. Can anyone explain why second update is unicast? And it will send total 16 unicast update message. After that, if it is still not receiving acknowledgement, then it will break the neighborship. Why second message is unicast? Second update message is unicast. Why not multicast?
With multicast, it has now found the neighbor. Then there is no need to send the message in multicast like to all the subscribers. Instead, you could just do a point-to-point unicast message.
Let's suppose R1 has two neighbor, R2 and R3. R1 and R3. R1 has advertised this network 10.1.1.0/24 to their both neighbor, to router number 2 also and to router number 3 also. Let's suppose router 2 has given the acknowledgement. Router 2 has given the acknowledgement to R1, but R3 has not given the acknowledgement, right? So if router 2 is going to read or retransmit update message on multicast address, then R2 will be also receiving that, right? R2 will again send the acknowledgement. So 16 times R2 will receive unnecessary update message. It has already given the acknowledgement. That's why R1 is going to send second update message on unicast address. It will send to R3 only, to that neighbor who has not acknowledged. Got it? That's why second message is going to be unicast. You can also perform this lab in your EVNG or even in GNS3. In GNS3 actually we cannot create hub and spoke topology. So whenever I will configure hub and spoke scenario or this kind of topology, I will use EVNG so that we can configure switch as well. Okay. So I am expecting query message is clear, like all 5 types of messages is clear to you. Now here is one more scenario in EIGRP. Let's suppose we have same topology R1, R2, copy, paste, and earlier in the topology table this submit was there 10.1.1.0/24. Now on the loopback interface I said shutdown. What will happen? R1 is going to send query message with delay infinity. What it will do? It will send a query message. This submit 10.1.1.0/24 and delay is going to be infinite. Done. Now router 2 should send 2 messages, one acknowledgement because query is a reliable message. Fine. If it will not send acknowledgement, we know what will happen. But what if router 2 is not going to send a reply? What if router 2 will not send reply? That is again dangerous scenario. Here EIGRP will stuck. How many of you have heard about stuck in active state?
No. Never heard of that.
Right, see, when everything is stable, everything is working fine, then all the routes will have state passive. Like you can check that in EIGRP table. So IP EIGRP topology. In the topology table here you can see this P stand for passive. This is a status of prefixes, EIGRP prefixes, right? Code P means passive and A means active. Active is the issue. If there is some issue, then state is going to be active. Passive means network EIGRP is stable, everything is working fine. So here you can see the status of all the prefixes in EIGRP topology table is passive. But sometime you will see some prefixes with state active. Right, and here a prefix or neighbor can stuck in active state as well. Whenever EIGRP neighbor is going to stuck in active state, it will break the neighborship. If it will break the neighborship, then it will re-establish the neighborship and it will re-exchange the routing table, recalculate the best path, means it will run the dual algorithm again on their topology table and it will find the best path, means routing table. Everything will happen again. That is again issue, right? So first of all, before talking about stuck in active state, understand this scenario. If router is not receiving reply, there are two use of query message, guys. Number one, to inform neighbor that if you have reachability, if you have learned this network via me, then remove it from your table. That's why it is saying delay is infinity from my side. And another purpose, if you have alternate path, then send to me. Reply can be negative or positive. If router will not send reply, it is fine to send a negative reply, right? If router 2 is going to send negative reply, means okay, from my side also delay is infinite for 10.1.0, then everything is going to work well. But if router 2 will not send a reply, then there is issue. And why it will happen? Sometime, you know, you will have topology like this. Let's say this is my data center router, right? This data center router is connected with two headquarter routers like this. These headquarter routers are connected with another branch routers. Right, like this. In this case, R1, if any prefix will goes down on R1, and let's suppose feasible successor for that prefix is not available, for this P means passive 10.1.1.0/24, and now this network goes down, right? Router 1 will generate query message. When router will generate query message for this network, the status will change to active. State will change from passive to active. Means query is generated for this subnet, for this network 10.1.0/24. R1 will send query to R2, R3, right? I will talk of R3 as well. Now focus on R2. Router 1 has sent query message to R2. Now R2 has two more neighbor, right? Here is also we have EIGRP neighbor. Here also we have EIGRP neighbor. So if R2 is going to receive query from R1, router 2 will send that query to their neighbor as well, and it will wait for reply message. When their neighbor will reply, then R2 is going to reply to R1. What it's saying, what is the meaning of query? That R1 is saying, hey, delay for this network from my side is infinity. Means remove it from your table via me, and if you have the alternate path, then send me. Router 2 is going to ask to their neighbor that, hey, delay for this submit from my side is infinity. If you have any better path, send to me as well. Got it? If these routers has another neighbor, they will ask to their neighbor, and R1 is waiting for reply. R1 is waiting for reply. Anyone have idea for how long R1 is wait for reply message? For how long R1 will wait for reply message? And when router is waiting for the reply, then state is active, right? If this network is directly connected over here on this interface and you have set the port, first router will remove this network from their routing table quickly, because the line protocol goes down, and it will change the state from topology table from passive to active. Then it will generate the query message, and now router is waiting for reply. And these router 2 and 3 will generate reply, will send reply to R1. When edge router will generate reply, one edge router will send reply, right? Let's suppose here I have lots of edge routers, right? Lots of branches. When these router will generate reply, it will give reply to this router will give reply to this router will give reply to R2, then R2 is going to give reply to R1. Sometime Because of congestion on the link also your reply message can miss. Right, router 2 have generated the reply but it has not reached to R1. What if R1 will not receive the reply and it will wait for reply for 180 seconds. Whenever a router generate query message, it expect acknowledgement within 180 seconds. Reply should come within 180 seconds. If router will not receive reply message within 180 seconds, then router will consider it as stuck in active state and then router will break the neighborship. If router 1 has not received reply from R2 within 180 seconds, it will break the neighborship. If it has not received reply from R3, it will break the neighborship. Here side by side I am starting GNS 3 also for a small labs. Here I can perform one small practical to understand this scenario in more better way. Okay. R1, R2, here I have one loop back. (10.1.0/24). What will happen when this loop back will goes down? To see the operation, we can capture the link. To see the operation which is happening behind the scene, I can capture this link and let me access these routers and let me configure the scenario very quickly. Remind me later. Here console. R1. (12.1.1) 255.255.255.0 interface loopback 1 IP address 10.1.1 255.255.255.0. Let me connect laptop to charger. And router EIGRP S number 10 network 12.1.1.0 wildcard 0.0.255 network 10.1.1.0 wildcard 0.0.255. Do so IP EIGRP interfaces. You can see EIGRP is enabled on both the interfaces. Let me take you to R2. Config T interface F0/0 no shutdown and IP address 12.1.1.2.255.255.255.0. Exit router EIGRP S number 10 network 12.1.1.0 wildcard mask 0.0.255. Do so IP EIGRP interface. Okay, done. So IP EIGRP neighbor. Done. Neighborship is up. Go to R1 and check topology table. So IP EIGRP. So IP EIGRP topology. In topology table, you can see the state of this prefix 10.1.1 is passive. And here is my capturing. Okay, if I will don this loopback interface, config T interface loopback 1 and shutdown. Here it will generate the query message. Here you can see the query. In the query, you can see it has set the delay infinity for this subnet, right? if you will open it and if you will check the wide matrix, then here you can see delay is infinity, and for this network, for this destination, and router 2 has given the acknowledgement as well as it has generated the reply. This reply is negative or positive? This is negative reply or positive reply? Huh?
Positive.
This is negative, na brother? If delay is infinity means router 2 also don't have any path. Delay from router number 2 to this network is also infinity. Means this is worst path. Right? So this is negative reply. Router 2 has sent the negative reply and router 1 has given the acknowledgement to the reply message. Okay. Now go to R1, say interface, loop back 1, again no cert. Will it generate query message again when I will no cert?
No.
No.
Which message it will generate?
Yes. Oh no, no shutdown. It's
Update
gonna bring
message
it
it
back.
will send.
Very good. It will generate the update message this time, not query message. And do so IP EIGRP topology. Okay. State is again passive. Shutdown. And it is removing the prefix quickly from their table because R2 is giving reply and even this interface is directly connected, so line protocol of interface will directly goes down. If it will happen for undirectly connected network and router is taking some time to get reply, then you can verify the state. Right here what is happening, R1 is receiving reply and it is removing the prefix from their topology table. Can I do one thing for testing purpose? I can do one thing here, no cert. I can block EIGRP packet on router number 2, but if I will block the EIGRP packet on router number 2, then neighborship will goes down in 15 seconds, right? I don't want that. First I will change the hold on time of EIGRP so that neighborship should not goes down. Anyone have idea how to change EIGRP hold on time?
No, sir.
IP EIGRP IP hello interval hold interval for EIGRP is number 10, and here you can configure the number from this range. This is EIGRP hold on time. EIGRP is number 10. IP hold on time, similarly IP hello time for EIGRP is number 10, and let me say like this. Let me copy this command and let me paste it on router number 2 also. Now my EIGRP neighborship will not goes down if I will block the EIGRP packet, right? Just I want to filter the reply. R1 will send query message to R2. R2 will not receive that query because of ACL. It will not generate the reply. In that case, see what will happen on R1. I just want to show you the state passive in real time. Many times you will see the passive, right? Whenever there is any issue of EIGRP configuration or routing loop, you will see some prefixes are flapping, right? Their state is changing from passive to active, and whenever state of prefix will change from passive to active in the topology table, there is chance of EIGRP fluctuation. EIGRP neighborship can goes down, it can break the neighborship. Let's suppose both the router has exchanged 500 prefixes, 500 subnets. So whenever neighborship will fluctuate, both the routers are going to re-exchange 500 subnets, right? So update message is going to be lengthy, the size will be large. That is not good thing. So on router number 2, what I am doing, I am just creating one access list number 101, deny, and here I can define the protocol, or I can define the protocol number. Protocol number of EIGRP is 88, so 88, and then host. If you are receiving any EIGRP packet from host 12.1.1 and destination, let's say any, right, for any destination, this is what extended ACL. And similarly, access list 101 permit IP any. Rest all the traffics are permitted. If I will apply it on F0/0 interface F0/0 IP access group 101 and direction in. Now if router 1 will generate query message, router 2 will not generate reply. Right? Do so IP EIGRP topology. Here you can see the topology table. This LAN submit is there and the state is passive. Now I am going to set the port again, and here is your capturing. Set the port, set, and do so IP EIGRP topology. Which port I have set? No set. I think I have set interface 0/0. I need to set interface loopback 1. I'm expecting for EIGRP neighborship again. Let me say port shutdown and do so IP EIGRP topology. Here you can see state is active. Why? Because here somewhere you will find the query message. R1 has generated the query message and R2 didn't generate reply. Where is query? Or let me do one thing again from R2 for just a moment. For testing, I am going to remove ACL once so that it will come on normal operation, no shutdown. Okay. So IP route EIGRP. Okay. Config T interface F0/0. And again I will apply this ACL. Before that, here interface loopback 1 and do so IP EIGRP topology. Okay, all good, everything is good. Let me say set. Here is the query message, you can see, right? Are you able to see any reply from R2? No. As R2 has not generated the reply, do so IP EIGRP topology.
Removed it.
Remove. Here it has sent the reply. That's why it's removed, right?
Yeah, it still sent the reply.
So on router number 2, let me apply the ACL. No, don't apply first. First up the port, no shutdown the port, and then apply the ACL. Okay. Now again both the routers are just exchanging hello message. I have applied the ACL. Go to R1 and say shut down. Now R2 will not generate reply. Here you can see query. Again it is sending query. First query was on multicast address. Second query is on unicast address. It will be sending query message after every or for 180 seconds. And for 180 seconds, the state is going to be active. This particular scenario is called stuck in active state. What we called it? Stuck in active state. And stuck in active state timer is 180 seconds. If you want to change, you can change that timer as well. Right? But after 180 seconds, you will see router 1 is going to break the neighborship with R2. This was a particular scenario of EIGRP. This is very dangerous in real-time network. So again, sometime interviewer can ask you a question like this, that if router EIGRP router has generated the query to their neighbor, but neighbor didn't reply, in that case what will happen? Right, so if neighbor will not reply, router will start sending unicast query message, or interviewer can ask you when router will send unicast query message or unicast update message. When router will not generate acknowledgement message after receiving update, sender router will start sending unicast update message to their neighbor. And in case of query also, when reply will not come, it will send the unicast query message, and after 180 seconds it will break the neighbor SIP. What is SIE time? 180 seconds. Now in EIGRP we have two types of neighborship, static and dynamic. Right now we are learning dynamic. In case of static neighborship also, router will, in case of static neighborship, actually router is going to send all messages on unicast address only. All the messages on unicast address only. Is there any solution for this? Yes, Praphul. Backup path. If there is backup path available in the topology table of EIGRP, then router will never generate query. Right? Now what is backup path? Let's understand here. I'm going to take a snapshot and let's understand the algorithm of EIGRP, dual algorithm. EIGRP uses dual algorithm for best path selection. Dual stands for diffusing update algorithm, right? And dual has some components, some parameters like FD, feasible distance, which is FD in short. Second component is RD, reported distance, in short RD. Third is successor, which is best path, and the last component of dual algorithm is feasible successor, in short FS you can say, which is backup path. Backup path means whenever best path will goes down, router will start using backup path. So if you want your EIGRP routing protocol should be always stable, then make sure there is feasible successor present in topology table. In my lab, here you can see on router number 1, so IP route EIGRP. Is it learning destination submit? What happened? I think EIGRP is not running on all the router. Let me enable it. Config T router EIGRP S number 10 network 0.0.0. Go to R3 config T router EIGRP 10 network 0.0.0. Go to R4, enable config T router EIGRP 10 network 0.0.0 and show IP EIGRP neighbor. So okay, good, two neighbors are there, and show IP route EIGRP. You can see for this destination there are two paths because metric from both sides is equal. Metric from both sides is equal. Here you can see on gig link, yesterday we had seen metric calculation on fast Ethernet link. Here I am using gig link, right? And we know one thing, that bandwidth is inversely proportional to metric. More bandwidth means less metric, and lower metric will always get higher preference, right? That will be installed in routing table. Here both the router R1 and R4 are calculating same metric from multiple path. That's why it has installed both the path in their routing table. If you will check topology table, so IP EIGRP topology, which is the database, then here also you can see for 192.168.2.0, this first number is what? This first number is FD, feasible distance. The second number is RD, reported distance. And the path which has lower FD will become successor, and the path which has higher metric can become feasible successor, backup path. That is not mandatory that every time backup path will become feasible successor. Let me take you to R3, and I am going to change the bandwidth of this interface. Let me take you to R3 and exit interface G0/1. Do so interface G0/1 include bandwidth. What is the bandwidth? Kilosecond.
100.
10 raised to power 6. Here if I am going to change the bandwidth, now you can see bandwidth is changed. Now router is not going to calculate same metric on both the path. Go to R1 and check routing table first. So IP route EIGRP. Now you can see for this subnet there is only one path in routing table. If you will check topology table, so IP EIGRP topology, here you can see how many paths are there for this destination. Only one. If I will show the all link, then also what? One path. That means R3 even learning this subnet from R1, not from R4. Let me increase some bandwidth over here for testing. I have to check by configuring multiple value. You have to check 2, 4, 5. Okay. Now let me take you to R1 and check the topology table. Or instead of manipulating bandwidth, see, even in the production you will be not allowed to change the bandwidth of physical interface. You are performing manipulation for EIGRP. You will not touch the actual bandwidth. So we'll understand how we are manipulating, how we'll control the path, not by changing the physical bandwidth or delay. Here I am going to remove this command first. Say no, and let me check the bandwidth is default or not. Yes, bandwidth is default. Instead of changing bandwidth, I'm going to change delay. So interface and delay. What is the delay? Delay what is delay? 10 ucosecond. Delay is 10 ucosecond, and here I am going to configure delay is directly proportional to bandwidth or inversely proportional to metric. Like bandwidth is inversely proportional, delay is directly proportional or inversely proportional. If we have more delay, means metric is less or
Directly,
more?
I think directly.
Directly, right?
It is directly, yeah.
Because even in the formula 10 raised to power 7 upon bandwidth plus total delay. Delay is directly proportional. If I am going to increase delay from 10 to 11 over here, router will calculate higher metric. Now delay is So it is multiplying delay by 10. Instead of saying 11, I am going to say 2. So here delay will be now 20. And now go to R1 and check the topology table. How many paths are there for this destination? 2. But how many successor?
1.
How many successor? 1. Leave it.
1.
FD is this one. This is the matrix total distance. Why this path is not successor? Why we don't have 2 successor? Earlier, if I will remove this command, then I will have 2 successor here. If I am going to say no to this, and then if you will check topology table on R1, then you can see we have 2 successors, right? But if the path is not same, right? Maybe router 2 and router 3 are ISP, not my company router, right? So bandwidth is different or delay is different. In that case, R1 is calculating different matrix, different FD. Again, I am going to configure delay 2 here, and here I can show you the topology table. Again,
So,
one
Praphul, I
successor.
am having one question regarding this. So, for to become successor, the matrix should be same.
Yes, correct. Absolutely. Matrix and AD both should be same. Wait.
Okay.
See here. Now I have single successor. Now question is, this path is the successor path, right? Because what it's saying, one successor whose FD is 3328. So this path has FD 3328. That means this path is the successor. Question, is this path feasible successor? If this path is the feasible successor and R2 goes down, router 1 will not generate query. If this path is not the feasible successor and then R2 goes down, then router 1 will generate query. Hope now you have understood when router is going to generate query and how to reduce the query with the help of backup path, by adding the backup path. So my question to you is this path feasible successor? Definition of successor, FD is total distance. FD is total distance from source to destination. RD is total distance. When I am saying distance, it means I am talking about matrix. RD is total distance from neighbor to destination. And you already know the successor, best path, feasible successor, backup path. So let's suppose here matrix is 10, matrix of this link is 5, matrix of this link is, let's say, 10, here matrix is 15, here matrix is 10 for an example, right? So router 1 is going to calculate FD and RD from both sides, from this side to reach in this destination 192.168.2.0. What will be the FD total distance? 10 plus 5 plus 5, 30 total distance from source to destination. What will be the RD total distance from neighbor to destination? 10 plus 5, 15, correct? Right, guys?
Yes.
From lower path also it is going to calculate FD and RD. What will be the FD? 10 plus 10 plus 10,
30.
30. It will perform what?
Load balance.
Load balancing. How many successors are there?
2.
2, right? Now, instead of using matrix 10, here I am going to change the matrix from 10 to, let's suppose I have configured matrix here 15. Now tell me. Yes.
It means RD in the other side, in the downside, it is 20, I think,
Yes,
isn't it?
absolutely.
Does it make a difference to get the successor?
Yeah, I am talking on. I will talk about that
Okay.
soon. Just a
Okay.
minute. What will be the FD now? From lower path? On the lower
35.
path, FD is 35,
35.
right? It means there is only one successor now. We don't have two successor. Only one best path. This path is the best path. But one question is still pending. Is this path feasible successor, backup, or not? Remember, all EIGRP path is not going to become backup path. There is one feasibility condition. If feasibility condition will match, then only this path is going to become feasible successor. If this path is the worst path, then router will not make it, router 1 is not going to make it even feasible successor. That depends on FD and RD. What will be the RD on lower path? 20, right? Total distance from my neighbor, neighbor of R1 is R3. From R3 to destination, distance is 20. That is RD. Now you can see on
Sir,
both
here,
paths.
sir, here I have a question that you are calculating the FD and RD on behalf of the R1 router or the R4. Means which one is
I am
source and which one is
calculating the
the
FD and RD of path,
okay.
not
So is
on
the
the
same
router.
okay, it's the same for the all routers. Means the EIGRP is calculating the same RD and FD for the storing the FD and RD for all routers in the EIGRP protocol. Means that is my question actually. They are calculating the FD and RD. It's EIGRP calculating, so it is stored. It's every topology table is stored the FD and RD, right?
Correct?
So it's R1. Yeah, all router have the same value for that. Means according to this topology. I mean the FD and RD will be the same for all the router will maintain.
How it will be
Means,
same? Like R2 is going to calculate their own FD. FD from R2 to this destination is going to be 15. RD is going to be 10 from neighbor to destination. This is the FD and RD from R2 to this network. Similarly, all the routers are going to calculate their own FD and RD. Router 2 will also calculate FD and RD from this path. Whatever path are available, on all the paths it is going to calculate FD and RD.
okay, okay, understood.
Okay, so here is the FD and RD of both path on router number 1 to reach in this subnet. Now what is feasibility condition? Anyone have idea? Feasibility condition is this path is the best, that is clear. Is this path backup path or not? No one knows this.
Yes, sir. Backup
Yes,
path
sir.
is.
Tell me
It's a backup path
feasibility.
because it's a equal and lower of the FD of the base path.
What it's saying?
The RD value is equal or lower.
No, there is feasibility condition for that. What is the
The
feasibility condition?
FD should be greater than the RD.
FD of successor, right? Means this 30 should be
Yes.
greater than or equal to RD of feasible
Feasible
successor.
successor.
Feasible successor. So what is the FD of successor? 30 greater than equal to. What is the RD of feasible successor? 20. Is feasibility condition matching?
Yes.
Yes, it is matching. That means this path is the backup path. But here if my matrix is, let's suppose 30, right? So RD is what? 30 plus 10, 40 here. Now is feasibility condition matching?
No.
No. Feasibility condition is not matching. That means this path will not become backup path. You will not find this path in EIGRP topology table. And if there is no backup path, no feasible successor, then router will always generate query message. Whenever successor goes down, router will generate query message for their all neighbors. And if any neighbor is not going to reply within 180 seconds, then it will break the neighborship. So here in my topology on R1, you can see this path. Here we can see that this is the FD of my successor, this is the RD of my feasible successor. I can check both are equal, right? FD of successor and RD of feasible successor are same. So feasibility condition is matching. That means lower path is the backup path, lower path is the feasible successor. If R2 bill goes down, router 1 is not going to generate query message. Simply it will install backup path in their routing table like this. So IP route EIGRP. Here you can see right now this network is reachable via 12.2. If router 2 bill goes down, interface G0/0 shutdown, do so IP route EIGRP. Simply it will change the next hop. Right now backup path become best path successor, and do so IP EIGRP topology. In the topology table now you can see we have single path and that is successor. Right, if we have single path then there is no comparison, right? Whatever matrix is there, that is the best only. But in production you will hardly find a single path between source and destination. Every time there will be multiple paths. It is similar like between, let's say, Mumbai and Delhi. If there is only one road, only one highway, you can imagine how many paths are there between two cities. Similarly in your networking also you will have lots of paths. I had shown you nodes on internet earlier, right? So lots of routers will be connected with each other. You will have multiple paths to reach one destination from one source, and your routing protocol will be finding the best path. It will be installing the best path in the routing table, and whatever path is present in the routing table, router will forward traffic through that path only. We know the packet flow as well. But here again, if I am going to up the port, say no set, and so IP route EIGRP. Now you can see, just wait. Now you can see routing table is updated. Best is via router number 2, and I have alternate path. So IP EIGRP topology. In the EIGRP topology table, you should have two paths, na? So IP EIGRP neighbor. 13.3 is also neighbor. So IP EIGRP topology or link. Okay. Here are these two paths. Now, right now your router is not performing load balancing. But if you want load balancing here, you can do that as well. Right? Instead of touching bandwidth, physical bandwidth and delay, what I told you, you will never touch that. You will never touch that. Let me remove this command here, the delay command. Config T do so run interface G0/1. This command is running. If I will remove this command from G1/0, again router 1 will start performing load balancing. But forget about this, that we have changed it. Just imagine this is the real bandwidth delay. In that case, can I achieve load balancing on R1, Praphul? Yes, you can achieve load balancing on R1 through EIGRP routing protocol. EIGRP is the only one dynamic routing protocol which can perform unequal cost load balancing, right? Unequal, see, if metric is same from both the path, then definitely router will perform load balancing, and that load balancing is called equal cost load balancing, because cost, which is metric, either I can say metric or I can say cost, meaning of both are exactly same. Metric, the distance. If distance is same from multiple paths to reach one destination, then router will perform equal cost load balancing. And all the routing protocols, OSPF, EIGRP, BGP, ISIS, are designed to perform ECMP, equal cost load balancing. equal cost multiple path. EIGRP is the only one routing protocol which can support ECMP as well as unequal cost load balancing, right? EIGRP can also support unequal cost load balancing. When cost is not equal, when matrix is not equal, then also we can install multiple path in the routing table of router. If you have installed multiple route path in the routing table of router, router will definitely perform load balancing. How we can do that? Anyone have idea? With the help of variance. What do we call it? 1 minute, guys. Variance. So variance is the EIGRP feature which is used to perform or support unequal cost load balancing. It is used to perform unequal cost load balancing. This is very important for interview as well. Interviewer is asking multiple times this question: how to perform unequal cost load balancing in EIGRP. Variance is nothing but 7 bits decimal values. So what will be the range if it is 7 bits decimal value? 1 to 128?
128.
Right? But variance is only applicable on, it is only applicable for feasible successor. Right, guys, even we are not using EIGRP, but these concepts are very important. Understanding ECMP, equal cost load balancing, unequal cost load balancing, because similarly we will see the load balancing in OSPF also, in BGP also. Right, maybe you will not have the variance feature in OSPF. Right, by the way, I have already told you that no any other routing protocol supports unequal cost load balancing. EIGRP only support this feature. Understand the technology, how it is going to work. So you know what EIGRP does by default for feasible successors. By default, variance value is 1, and variance is the multiplier of successor FD. Right, variance is multiplier of feasible successor FD. Sorry, I'm saying feasible successor, feasible distance. So whatever feasible successors are present in the topology table of EIGRP, right, it is going to multiply their FD by variance value, which is 1, and the output is going to be exactly same, right? Like in my case here, you can see in the topology table of R1, so IP EIGRP topology or link, you know, this is the successor best path and this is the backup path. Correct? This is the backup path. If this is a feasible successor, then you can install this path also in the routing table with the help of variance. So what happened? Actually, your router EIGRP is multiplying the FD of feasible successor by variance, means this value multiply by 1, and output is going to be what? FD. I'm so sorry.
Same.
FD of successor. This value by 1. Output will be same. You will get this value only. And now EIGRP is going to look up their topology table. Is there any path whose FD is lower than this value, multiplied value? If yes, then install that also in routing table. That is the concept of variance. Means variance is a multiplier of FD, FD of successor. Your EIGRP router is going to multiply feasible successor FD by variance value, and it will look up for feasible successors. If there is any feasible successor available whose FD is lower than multiplied value, it is going to install that in their topology table as well.
Sir,
1 minute. Interface G0/1. 1 minute. Delay to say no. What was the default delay on gig link? Do so
10, sir,
interface
10.
G0/10.
It was 10.
Let me change it on R1. Interface G0/1 delay to show IP EIGRP topology. Okay, see, this is my successor. This is the FD of feasible successor, and here is the RD of feasible successor. So RD of feasible successor is lower than FD of successor. That means this path is the backup path. But why router is not installing it in routing table? So IP route EIGRP, because by default variance value is 1. If I will change the variance value from 1 to 2, then multiplied value is going to be what? Let me check. If I will multiply FD, means 3 to 8 multiplied by 2. It is going to calculate this value. Now check, the feasible successor FD is lower than this value. Yes, router will install it in routing table. Let me try with variance 2. Router EIGRP, yes, number 10, and variance, let me say 2, and so IP route EIGRP. See, is matrix same? Is matrix same?
no.
No.
But
No.
still it has installed in their routing table, means it will use both the path to forward the traffic. This is what? This is unequal cost load balancing. Only EIGRP protocol support this. You can only achieve unequal cost load balancing in EIGRP. Otherwise, in all other routing protocol, you will only find multiple paths when cost is same. Variance is also clear. How to find the variance value for load balancing? You can divide FD of feasible successor by FD of successor. You can find the variance value. If you are getting variance value, let's say 1.5, so you will use 2. You need to check with what value I need to multiply FD so that my feasible successor FD can be lower than multiplied value. Whatever path is available in topology table whose FD, means total distance metric, is lower than multiplied value, will be installed in routing table. That is the power of your variance in EIGRP. Through variance, we can achieve unequal cost load balancing. Great. Again, I am going to configure router EIGRP 10, and I am going to remove this command variance 2, say no. Again, router will install single path in routing table. So IP.EIGRP you can see, right? Only successor, feasible successor is not installed. So IP EIGRP topology you can see, right? Only one successor. Now, can I achieve load balancing here, Praphul, without using variance like equal cost load balancing? Yes, guys, you can use it. That is to achieve load balancing as well as path manipulation, right? To control the path. There is one more feature in EIGRP called offset list. Offset list. What is offset list? Anyone? It is used to perform equal cost load balancing. Variance is used to perform unequal cost load balancing. Offset list is used to perform equal cost load balancing. Question: how? So with the help of offset list, you can add some metric in existing metric. For an example, on router number 1, here in the EIGRP topology table, you can see this is the metric of feasible successor. This is the metric of successor, right? So if I will open my calculator and if I will subtract this number, FD of feasible successor is 353584 minus, if I will subtract the successor FD 328, then here is, you can see the gap, right? There is difference of this metric 259. If I will add this metric in the feasible successor FD, then both the path will have equal metric and router will start performing equal cost load balancing. See, router don't know anything about EIGRP. Router knows their routing table. Router forward traffic based on routing. If route is available, it will forward the traffic. How you are installing the route in routing table, that is different concern. That for that only we are using routing protocol. For that only I am running EIGRP. So all the routing protocols has their own mechanism, own features for load balancing to control the path. Offset list, variance is also the same thing. Offset list is also one of them. Variance is also one of them. Variance for unequal cost load balancing, offset list for equal cost load balancing. So I can simply add this value in the metric in the FD of feasible successor with the help of offset list, and once router will have same metric, it will install both path in their routing table. So it is used to perform equal cost load balancing. How you can manipulate the path through offset list? See here, what I don't want to change bandwidth, or you are not allowed to change bandwidth and delay, physical interface bandwidth or delay for path manipulation. But here you want to prefer lower path over upper path. Router should install this path in their routing table. So there is difference of this metric. What if I will add 260 in this FD? Automatically this path will have lower metric and router will install this path in their routing table. That way we can manipulate the path as well, right? So offset list is used to perform equal cost load balancing as well as for path manipulation. Let me show you how you can use offset list. First of all, if you want to add metric with prefixes, you have to match the prefix first with which prefix you want to add the metric, and to match the prefix I will use, to make interesting traffic I will use ACL.
Access list.
Yes, access list. That's why we had discussed ACL yesterday, because from here I am starting using ACL to match the prefix. Access list number 10 permit and 192.168.2.0 wildcard mask 0.0.255. So this access control list is matching, guys, this subnet, right? The destination network. You can match multiple subnet as well. Through ACL, I have make this network interesting. This is my interesting traffic. Sometime I will call it like interesting traffic. Now through offset list, I can add metric. Go to EIGRP router, EIGRP ES number 10, and here say offset list, and call your access list number 10, right? So I'm configuring offset list for all the prefixes which are matching in my ACL number 10. Then put question mark. You can see in which direction you want to apply, in direction or odd direction. So I want to add metric when router 1 will receive traffic on G0/1. It will not traffic prefixes when it will receive the update message in direction. Direction is in. After that, what value, how much offset you want to add? 256 or 259, I think, right? There is difference of
260, you said.
Huh?
260.
If you will
To make
configure
it
260, then lower path will
it will
become
be
best
okay,
path.
equal.
Yes. No. If you will add 259, then it will become
it
equal.
will be equal.
Yes, exactly. I want to make equal only.
But you want to make it higher, isn't it?
No.
Okay.
That will be for path manipulation. So it will, I'm going to add this value in my feasible successor. Okay. Command is offset list number 10, direction in, and value is 259. And after that, here on which interface? Interface Giga Ethernet 0/1. Now whenever EIGRP is going to receive any update message on 0/1 interface, it will add this value in metric in FD. Do so IP protocol. Through IP protocol, you can verify it. Here you can see EIGRP neighborship is resync. So IP protocol. My routing protocol is EIGRPS number 10. No any filtering applied. But for incoming route in G0/1 will have 259 added to metric if match, if on list 10, if the prefix will match from access list number 10. Now let me show you the topology table. Do so IP EIGRP topology. Now you can see this subnet. What happened? That's only one path. Do so IP route EIGRP. Do so IP EIGRP neighbor. Do so IP EIGRP topology all link. No, I have added wrong value, correct? Let me remove this command.
Yeah. Might be 00.
No. Tell me the difference. Value.
263.
59.
263.
69.
No, 59.
259. Earlier I had 259 only. No? Okay, it was.
Yes, you can read it in show.
259. Okay. Now.
You still make a wrong interface. Interface is 00.
No, it's 01 na. So IP EIGRP topology. No, still there is. Let me check.
Yeah, because before you make it 01, now you have to make it.
Okay,
you want
add,
interface 00.
I am adding metric on 0/0. Correct.
Exactly.
Router EIGRP 10. Say no to this and
Yes,
0
200.
slash 0. Great. Thank you.
Yeah.
So IP EIGRP topology. Just wait for resync and now check EIGRP topology. And now you can see here still value is not correct, brother. Router EIGRP number 10. No. Do so IP EIGRP topology. Calculator. Okay. Actually, now I got it. Why it's not happening? Anyone? Anyone can tell me why it's not working? Topology table. In topology table, two paths are there, and through offset list, why I'm not able to perform equal cost load balancing? Check the value. 3584 minus 3328. I need to add this value, right? So let me correct it here. 256 and wait for EIGRP resynchronization, and after that you can check the topology table.
No offset, should be offset.
नो दे दिया सर आपने उसमें.
राउटर EIGRP नंबर 10. एक बार गलती होता है तो यही होता है ना दिक्कत, बार बार फिर. ओके ठीक है. अब सो IP EIGRP टोपोलॉजी. गड़बड़ हो रहा है कहानी.
Sir, we have removed variance or not? It will cause issue. Variance.
So IP protocol, what is the variance value? I think variance is 1 only. So IP EIGRP topology on link.
Now it's equal. Now they are both equal.
Okay. In simulation, it was taking some time. This is what? Load balancing. This is what? Load balancing with the help of variance. In topology table, it's not showing. In all path, it's showing. And in the routing table, both paths are installed. But metric is same, cost is same. So we will call it equal cost load balancing. Here, if you want to manipulate path, you can do that also. Right? Earlier, best path was via router number 2. If I will add more metric, router EIGRP 10, and in the offset list, if I am going to say instead of 256, 257, the lower path will become best path. Just wait. And here you can see lower path is now best path. Can I remove it? So IP protocol. Is there anything configured now? No. Everything on default, no filtering. Great. Now again, topology is on default. So IP route, EIGRP, best path is via router number 2. So here I have talked about two features of EIGRP for load balancing and path manipulation. Another is summarization. Through summarization also you can achieve load balancing and path manipulation. You all know summarization. The meaning of summarization is summarizing prefixes. For an example, I have routers like this: R1, R2, R3, and R4. And guys, I will give you one video for SIA, right? You need to watch that video. You will learn something more about stuck in active state. If you want to learn, otherwise you can ignore it as well. Right? Every time I am not talking much, but there are some more things like changing the SIA timer, and something happen when router is stuck in active state as well, right? That it also generate SIA query, and SIA reply is there. So you can learn those things also. I will give you one video. Let's suppose here on router number 1 I have some prefix 10.1.0/24, 10.1.2.0/24, 10.1.3.0/24, and 10.1.4.0/24. First of all, if this network will goes down, let's say any loop back goes down on router number 1, router will generate query message, correct? Router will generate query message. Definitely yes. If you want to avoid that query message, I have told you to add the backup path, right, for the destination network on any router. It is not on router number 1 only. Let's suppose on router number 4. On router number 4 also, if any path this network will goes down, router 4 will generate the query message. To reduce the query message, we can add the backup path. Another way is we can perform summarization, right? If I will advertise a summary address instead of advertising this all individual address to EIGRP neighbor, then router will never generate query message until and unless any one subnet which are part of the summary address is up, right? Like instead of installing this, router 4 is going to install prefix like this: 10.1.0.0/ let's say 16, right? Now if this network goes down, router will not generate query, because still some prefixes which are part of that summary address is available, is up. When all the prefixes which are part of summary address goes down, then only it will generate the query message. So if interview is asking you this question, how to reduce the number of query, you should include two things: one, add backup path; second, perform summarization. With the help of summarization also we can reduce the query. Why we are reducing query? You know the stuck in active state scenario. Through summarization, Praphul, how we can achieve load balancing, understand, or path manipulation? See, what will happen in normal scenario? If here I have configured EIGRP between all the routers, router 1 has 2 neighbor, router 2, all the routers has 2 neighbor. So R1 is going to advertise these all prefixes to their neighbor. R1 will advertise it to R2 as well as R3. R3 will advertise, or R2 will advertise to R4, and R3 will also advertise to R4. Even R4 will advertise this update message to R2 also, but it will not do that because of a split horizon, right? Because on this interface it is receiving same network information, so it will not advertise. That is a split horizon only, and by default split horizon is enabled. So split horizon will avoid the loop here. So R4 is learning this subnet from two side, from two neighbor, from router 2 and router 3. It has installed all the prefixes in the routing table, and it will be performing what? Load balancing by default if the bandwidth and delay is same on both the path. That means these prefixes are reachable via R2 as well as via R3, correct? Now from both sides, R1 is advertising all individual prefixes to both the neighbor. Let's suppose here, instead of advertise all individual prefixes, I have advertised summary address 10.1.1. or 10.1.1.0.0/16. I have advertised this. Not all individual prefixes. Now router 1 will not advertise these all individual prefixes to router number 2. How router 2 will learn all these individual prefixes? From router number 3. So in the routing table of router 3, you will have this submit 10.1.10.1.0.0/16 via R1 and 10.1.1.0/24 via R4, 10.1.2.0/24 via R3, 10.1.3.0/24 via not R3, R4, again via R4, and 10.1.4.0/24 via R4. This will be the routing table of R2. In the routing table of router 4 also, you will have one more prefix. These all individual prefixes will be reachable via R3 only now. Not reachable via R2, only reachable via R2. Sorry, R3. And one summary address 10.1.0.0/16 is reachable via R2. In the routing table of R3, you will have all these individual prefixes, and all individual prefixes will be reachable via R1. It will be reachable via R1, and one more prefix 10.1.0.0/16 reachable via R4. This will be the routing table of R3. R3 will also advertise this summary address to R1, because this time you can see R3 is not learning same prefix, not receiving same prefix on this interface. SP Horizon will not stop this. R3 will advertise this summary address to R1 as well, and R1 will not accept it, right? You know, actually something else will happen here. Whenever you perform summarization on any router, EIGRP summarization, router is going to install this summary route in their local routing table as well on null 0 interface. Null 0 interface to drop the traffic, right? It is like this network is connected on null 0 interface. So when router 3 will advertise it, it will compare with this one, this, and router 1 will prefer this one. It will not accept, it will discard the update message which is coming from R3. That is to avoid loop in case of summarization. During configuration, I will discuss more if you will have any doubt about this entry, right? But you will only find this when you will perform the summarization here. Forget about this also. Now see, before performing summarization, router 4 was performing load balancing, right? For this subnet, right? Both the path was best. After performing summarization, when I had started advertising summary address to R2 from R1, now if someone is going to ping 10.1.1.1, right? This LAN user is connected on router number 4. Router 4 will forward traffic to whom? Will it perform load balancing? Will it forward traffic to R2, or it will forward traffic to R3? Tell me, to whom it will forward traffic?
To R3.
It will forward the traffic to R3. This, don't you think this is path manipulation again? Before summarization, load balancing was happening. Now best path is via router number 3. Through summarization, you can reduce query as well as you can manipulate the path. If I want to forward traffic via router number 2, I will advertise the summary address to R3, not to R2. Again, I can manipulate the path. Through summarization also you can achieve path manipulation and load balancing. If you will advertise summary address from both the side, 10.1.0.0/16 only. Again, router 4 will start performing load balancing, and we have summarized the routing table as well. And we have summarized the routing table as well. That is the benefit of using classless network here, 10.1.0.0/16. If I am using classless network, very easily I can summarize the routing table of any router. Earlier it was installing 4 prefixes. Now it is installing single prefix, but this is not the correct way to perform summarization, right? We'll calculate the summary address manually. Otherwise, you know, there can be one issue. For an example, if I will use class full summarization, let me give you an example: R1, R2, R3, and here is one LAN user. Here I have subnet 10.1.1.0/24. Here I have subnet 10.1.2.0/24. Right? In case of automatic summarization, both the routers are going to advertise class full summary address 10.0.0.0, 10.0.0.0. This is what? This is called auto summary. And in this case, auto summary. Here is the issue. If this LAN user whose IP address is 192.168.1.1, when this LAN user will ping to 10.1.1.1, maybe this router will forward traffic to router number 3. Right? Because router 2 is performing what? Load balancing. Router 2 don't know that 10.1.1.1. So the classless network is reachable via R1 and 10.1.2.0/24 is reachable via R3. Router 2 is thinking same service, same subnet is running behind router 2 and router 1. So randomly router 2 will be forwarding traffic to router 3 and router 1 as well. Right? This is issue of auto summary. Here I am talking about manual summarization. Here we will perform manual summarization. Right? So in EIGRP, for path manipulation and load balancing, we had seen 3 features today: variance, then offset list, and then summarization. Now it's your turn to practice it so that we can move further in next class. Right? There are so many other ways. Here my concern is even not to teach you the offset list or variance and summarization. Definitely this is important and you have to understand. But there is something more than that. That is understanding the behavior, right? So that we can understand all other dynamic routing protocols. So how variance is performing unequal cost load balancing, how through offset list we can achieve load balancing as well as path manipulation, how through summarization we can achieve load balancing as well as path manipulation. So these are 3 features of EIGRP which we are using for path manipulation and load balancing. Right? On the router you can test one thing here. Let me do one thing on router number 1. Just I am going to create some loopbacks. Interface loopback 1, IP address 10.1.1.255.255.255.0. Interface loopback 2 and IP address 10.1.2.1. Interface loopback 3 and 10.1.3.1. If I will advertise the summary address, see on router number 4. On router number 4. So IP route EIGRP. Right? For this all subnet it is performing what? Load balancing. If you will trace route 10.1.1 and source G0/2 numeric, you will discover both path, right? 24.2 and 34.3. Router 2 and router 3 both are the next hop. But as soon as I will advertise summary address from G0/0, let's say, means to router number 2, interface G0/0, IP summary address for EIGRP as number 10, let's say 10.1.1. or 0.0, and subnet mask 255.255.0.0. Now you can check R4 routing table. Now in the R4 routing table, so IP.EIGRP you can see, right? It is receiving all individual prefixes from R3 and a summary address from R2. If I will trace route now, then my all traffic will go via router number 3, 34.3 only, right? Now router 4 will not send any traffic to router number 2. And what I told you, router 1, whenever we will perform summarization on any router, it will install that summary route in their local routing table as well. So IP.EIGRP, here you can see this summary address. On which interface? On null 0 interface. Why? To avoid loop. Otherwise, router 1 can learn same summary route from R3, right? It can come from this side. Right? But whatever offset list you want to configure, you have to match the traffic first. You have to make the traffic interesting first. And for that, I will be using access list. There are some more features like prefix list. We can use prefix list as well. Like here I have used what? To configure offset list on router number 1. Router EIGRP, yes, number 10. Offset list number, put question mark. Here you can see. This is what? Standard ACL. This is what?
Extended
ACL, right? We have even no talked about the other range. This is extended ACL, and here named ACL. Here we don't have option to match prefixes with prefix list. But in route filtering, if I am going to say distribute list here and question mark, then you can see here we have prefix list option as well. So prefix list is also similar like ACL, but there is some differences. In prefix list, you can match the prefix based on prefix length, right? Then we have route map as well. So we need to understand these three things: ACL, prefix list, and route map for path manipulation and route filtering in all dynamic routing protocols. After few classes, I will talk about prefix list and route map as well. For today, that's all.
Sir, I have a question actually.
Go ahead.
Can you open the paint once?
Okay.
Sir, here I have a question that why the R3 is the best in this path for this scenario for the summarization.
No, R4 is performing load balancing here.
No, you asked that which one is the best path for this. So
if R3 is advertising all individual prefixes, then right now if I will ask you R4 will forward traffic to whom, you should say load balancing. It will send to both the next hop, R2 as well as R3. But if R3 is not advertising the summary address, here I am not advertising summary address, in that case router 4 is learning 10.1.1.0/24 from R3, right? And
because
this user,
it's okay, so because it's a more precise than the /16, that's why it's choosing the base path for the
definitely.
Okay. And my second question is that sir, when we are summarizing the /16, it will allowing the multiple prefix means in the networks.
Correct.
So is it possible to summarize between these four, or which we are required in the small network as per
Definitely
our?
possible. That's only I told you, yesterday we will see the summarization, manual summarization. How, what will be our summary address to match these prefixes only. If I am using /16, that means I have summarized 1.02, 10.1.255.0, all the subnet, all are summarized, all are the part of my summary address.
Yes, sir. But if it we not required for the multiple, means we require the 1, 2, 3 instead of the whole /16 network. Is it possible
You
to
can do
summarize?
/22 at that point. So route summarization for
how to calculate that?
/22.
Do you know
So
the
Forget the
process?
that's what I'm
subnetting.
saying, like
Convert it
10.1
into
dot.
binary. Like first check where is the change. Change is in third octet, right? In third octet,
Yes.
in first subnet, my value is 1. So binary is going to be 7 times 0, 4, 5, 6, 7, 1. This is my binary of 1. The binary of 2 is 1, 0. Binary of 3 is 1, 1. Now check how many bits are common. So 6 bits are common over here, right?
Mhm.
In first octet 8 bits, in second octet 8 bits, 16 bits and 6 bit here. So 8 plus 8 plus 6. What will be the value? 22, right? So your summary address is going to be 10.1.0.0/22, right?
22.
This
There
summary
you go.
address is
Yep.
only matching the upper three prefixes.
Okay, sir. Is the summarization discussed in the IP segment in the IP addressing?
We had discussed summarization
Okay.
in subnetting.
Okay, subnetting. Sorry. Okay. Okay, I go for that video actually. And my last question is that can we manipulate? You said that earlier that some devices are using the K4, right? The metric value, the K4. So can we use that for the manipulating which devices have the K4 activated, the metric value? Can we use that, or can we use that the delay, the K2 value?
You
Sorry,
can
load
use
value. Sorry,
any K
load.
values. You can use
Okay.
K1 to K5 all values to calculate metric. By default, Cisco router uses
K1
K1
and
and
K3.
K3
Bandwidth plus delay.
because these two are
Yes.
the fixed components.
So for the safer side, we don't need to be manipulate the K1 and K3 by default. So is there any safer side to we need to manipulate the load, the K2
See, we are
metric?
not manipulating anything here.
Okay.
This is K values to calculate the metric. Router should use same K values to calculate the metric, then only neighborship will form.
There will be come. Yep.
Otherwise, neighborship will.
Okay.
This
So
is not for path manipulation.
Okay,
you can
only
use
for the
variance
neighborship.
offset list and
Okay,
summarization to change those
manipulation
just
thing.
change
Okay,
the path. Yeah.
okay,
Not the
For
K1 and
path
K3.
manipulation, till now we have discussed these three components, these three features only.
okay,
Variance,
sir.
offset list and summarization.
For the neighborship, we need to concentrate on the metric values.
Correct.
Okay,
Yes.
okay, sir. Thank you.
Right. You can also control the path. You can manipulate the path by changing the number like bandwidth, right? K values, not what K values use. Here I was talking about what K values routers are using to calculate the metric. But by changing bandwidth also I can manipulate the path. By changing the delay also I can, that is defining the bandwidth value. Again, that is another thing.
Okay,
But
sir.
again, that is related to metric, na?
Correct. That is, yes, that is path manipulation. We can do
Right.
path manipulation with the help of bandwidth, delay, or whatever K values routers are using to calculate the metric. If router is using K1 and K3 and if I will change the K4, there will be no any effect.
But you told us it's better to do not use, isn't it? If I get you right.
Yes.
For
Use K1
bandwidth
and
and
K3
delay.
only. Correct. Absolutely right.
Thank you. Okay, so I think we have finished
Yes, we are done with today.
So,
for
Praphul,
today.
I am having
Okay,
one
Please
so
share
don't
the
question.
forget
recording.
Praphul
the
I'm
record.
asking question. Okay, what yesterday I was asking.
Yeah,
So
now
can I
share your
present
screen.
my? Yeah, okay.
Sir, please share the recording.
Let me upload
Sir,
that.
Praphul,
Go ahead.
Praphul. Yeah, I really need that the recording for yesterday.
So Praphul, this I have
ACL recording.
created.
Okay,
My,
brother. Just wait.
my
Let me see
my
here.
screen is visible.
Yes, your screen is visible.
So this I am able to ping this PC2 IP from here. Okay, this you can check it also. Okay, so I have assigned this IP, so I can able to ping from here to here. But if I'm pinging from here, I have defined static route in all the routers. Okay, so if I'm able to ping this, okay, from here, from this router, I'm not able to ping.
Check routing
So
table. what you did for troubleshooting here?
So I have checked the routing table also. Okay.
Try to give
And
exit interface.
No. Just check the packet flow. That's it. Nothing else. So IP route where destination is matching. It is forwarding traffic to 10.1.2.1. Where is 10.1.1.2? 10.1. Go to this router. Check routing table there. .1.1.2.
this is
Yeah, go there. Go to 35.2. Directly connected on which interface? G0/0. Now check here routing table for 10.1.1.0 on this router. This router will generate reply.
okay.
Right? For whom? For 10.1.1.
Right.
Check the routing table.
The 20 and 10 is
Where is
missing
route?
here.
Route is not present for the source. How ping will work?
But how it is happening for this PC? Because this is routed by this
So when
only.
PC will ping, then source is going to be 192.168.1 dot something. When router is pinging, then source is 10.1.1.1. If you will check packet flow, definitely you can troubleshoot the issue.
Okay. Okay, you mean to say that PC source will be 192.168.1, right?
Correct?
And here source will be 10.1.1.1.
Correct?
So this route it is not present in this router, right?
Correct? Even from the router also you can ping. Just update the source address. If you will
Okay.
update the
How?
source address, then ping will work. Ping IP address and source 192.168.1.1 or 100.
From here.
Praphul,
Yeah.
Praphul, I sent you configurations on your number.
This command is not available in packet tracer or available. Wait, na brother, let me finish here, na.
It is not available. Source is not
Angura,
available.
just wait. Let me finish.
Just
this command is
ping
not available here.
192.168. No, sir, it's there actually.
If
Like,
it is
the
there, then you
different way
can
you need
use
to.
it.
Yeah, there's a ping 192. Yeah, this is just press the ping. Yeah, enter. Just enter. Yeah,
Protocol,
type
okay.
the
Enter.
just enter. Yeah, IP address,
Target
source
IP
IP address. Yeah, target IP address. Enter. Enter.
Repeat. 5. Okay. Okay.
Enter.
Okay.
Enter. Here you need to be source. I'm mentioning the source command, I guess.
Not 10. From 10 you are not able to ping, na bro.
So what need to?
Source LAN interface IP address.
So LAN is
192.168.1.100.
Okay.
Say yes here. Type Y. Enter. Define source here. 192.168.1.100. Yes. Enter. 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 Enter multiple times. Hit enter. Hit enter. See, ping is working.
Okay.
Now you can stop sharing your screen. Yes, who was asking something?
Just before you go another step, why he said inter so many times? Why doesn't ping?
It was asking for other information, sir. I set all the things on default, like how many packet you want to send, what should be the timeout, what should be the source, what should be destination. So just I have set the target IP and source IP, and rest everything I have leave on default. It is like that.
You don't have to change those variables unless you have to manipulate the path or values.
Correct.
Sir, please share the